So as you saw in the previous clip, Luigi was cruising along the racetrack in Yoshi Valley in his go-kart when Bowser came cruising along in the opposite direction in his monster kart and crashed into Luigi. Both karts had an initial velocity of 508 meters per second and both stopped in 2 seconds. The first part of the problem wants us to figure out the net force needed to stop Luigi's go-kart. To do this, we first need to find the initial momentum of his go-kart. This is because we will be using the momentum principle later to solve for F net, or the net force. So we'll start by setting P initial, which is notation for the initial momentum, equal to the mass of Luigi's kart times the velocity of his kart, as seen in this reference equation. Luigi's kart is 75 kilograms and his velocity is 508 meters per second. Multiplying 75 by each component of the vector gives us 375, 600 kilograms times meters per second. Next, we need to find Luigi's final momentum, as the momentum principle uses the change in momentum, which we will find after this step. Luigi's final velocity is 0, 0, 0 because he is no longer moving. Thus, when you multiply the vector components by 75, you get 0, 0, 0 for the final momentum as well. Now we can finally solve for delta P, the change in momentum, by subtracting the initial momentum from the final. We subtract the final by the initial because we start at some point and end up at another, and we want to know how something changed between those 2 points. So plugging in values 0, 0, 0 minus 375, 600 gives us negative 375, negative 600 for delta P. Now comes the momentum principle, which is quantified by this equation here. Again, we plug in values we know or have found previously to solve for F net. We know delta P, which we just found to be negative 375, negative 600, and the change in time is 2 seconds because that is what was given to us in the problem. It took Luigi 2 seconds to get from his initial velocity of 508 to his final velocity of 0, 0, 0. So now that we have all of our values plugged in, we can solve for F net by dividing both sides by 2 seconds. The seconds cancel out, and dividing each of the vector components by 2 gives us F net of negative 187.50, negative 300. Solving part B follows the same steps as before, only this time you're substituting 250 kilograms for the mass. You would solve for P initial, P final, delta P, and use the momentum principle the same way as before. And so your final answer would be a net force of negative 625, negative 1000 to stop Bowser's kart. For the final part of this problem, since we already did the bulk of the work in part A, the only step we need to do is the last one involving the momentum principle. We already know delta P, so we reuse negative 375, negative 600 again and set it equal to F net times 1 second. Dividing both sides by 1 second yields the same vector, negative 375, negative 600, but only this time it pertains to the net force and not momentum because the units have changed to kilograms times meters.